In this video, we are going to solve a few problems on interference. So here we have got a coherent beam of red light of wavelength 650 nanometer. That's lambda in nanometer. So we'll convert that into meter. That is 10 power -9. We multiply it with 10 power -9. Through two slits S1 and S2 as shown below, bright and dark fringes are formed on a screen placed 1 meter from the slits. So the slits and the screen, they have a distance of 1 meter between them. So that's the value for L. L is equal to 1 meter. The spacing between consecutive bright fringes is 3 centimeter. So that's consecutive bright fringes. That means that's the value for XM, which is equal to 3 centimeter. We'll convert that into meter because it's in centimeter. Divide by 100 and we'll get that as 0.03 meter. Now that's on the diagram. I have labeled the central bright, and 3 centimeter away from the central bright we have got the first bright fringe. That means M is equal to 1. So you can see that M is not given in the problem statement itself, but in the diagram we can see that M is equal to 1 because 3 centimeter is the distance of the first bright fringe from the central bright. Now it's asking you what type of interference causes the bright and the dark fringes on the screen. So bright fringes are caused by constructive interference. That's what we have to identify. And dark fringes are caused by destructive interference. Next, the question is, what is the distance between the two slits S1 and S2? So the distance between S1 and S2, I have labeled it on the diagram. That's D, slit spacing. So D is not known to us, so we'll put D equal question mark. Then the formula is XM equal M lambda L over D. We have got the numbers for XM, M, lambda and L. D is missing, so we write the formula with D missing. Now we can cross multiply, or you can use shift solve on the calculator. I'm going to cross multiply here and then divide both the sides by 0.03 to get the final answer of D as 2.17 times 10 to the power -5 meter. Next, part C of the same problem is asking you, if the distance between the two slits is decreased, what happens to fringe spacing on the screen? So what I've done here is I've written the formula again to keep it in front of our eyes so that we can see what's the relation. So distance between the two slits, that is the slit spacing D, is decreased. We can see in the formula XM and D, they are inversely proportional to each other. That means if D decreases, XM will increase. So fringe spacing will increase. That will be our answer. Next, if the red light is replaced with a blue light, so we know that red light has a greater wavelength, greater lambda than blue light. So what the question is telling you is the lambda is decreased. So you're moving from red to blue, that means lambda is decreased. So what happens to fringe spacing? That means what happens to XM. Again, in the formula, we can see that XM and lambda, they have a direct relation. Lambda is coming on the top, just like XM. So they have a direct relation. That means whatever happens to lambda will happen to XM. So if lambda decreases, that means XM will also decrease. So fringe spacing decreases. Now in this problem, it is similar to the previous problem, but one of the parts of the previous problem. Here it says that what will happen to fringe spacing if the wavelength is decreased. So that means XM, what will happen to XM if lambda is decreased. So again in the formula, XM and lambda, they have a direct relation. So if lambda decreases, XM will also decrease. That means fringe spacing will decrease. Now similar problem, but two things are changing here. So here it's saying you have got a double slit interference pattern. The fringe spacing for a blue light was found to be X. What will be the new fringe spacing if the slit separation is halved? So we'll write the formula to keep it in front of our eyes. So they say that D is made half, slit separation or slit spacing is halved, and the distance from the slits to screen is doubled. So L is made 2 times of L, means L becomes double. So what will happen? The new XM we'll write m lambda 2l. So in place of l, I'll write 2l, and in place of d, I'll write d over 2. Now just focus on the numbers. So on the numerator, you have got 2, and the denominator, you have got a half. So that means what we are supposed to do on the calculator to get the answer is, we'll do 2 divided by 1 over 2. In the numerator, you have got 2, in the denominator is 1 over 2, and the factor comes out as 4. That means xm increases by a factor of 4.